doubt in this, then you may ask. Okay, so let us start. There are now types of singularity, types of isolated singularity are there. So the three types of singular point या singularity. Okay, what do you know? If f has an isolated singularity, then what do you know? I can write at Lorentz series representation. I can have, if f has an isolated singularity, singular point, then f of z has Lorentz series. Lorentz series representation, and what is that? Around z equal to z naught, say point z naught अगर मैं बोलता हूँ z naught is my singular point, then what can you write? F of z equal to summation n equal to 0 to infinity e n z minus z naught raised to n plus summation n equal to 1 to infinity b n upon z minus z naught. करेक्ट, यही था ना? Yes. So actually these three singularities, they depends on this term. This is called principal term, this is called analytic term, which I think I already told you. This is called principal part. Since suppose ये part नहीं है, so this part is there, then this is just like a polynomial, so you differentiate, integrate, there is not at all any issue. So this part is called analytic part and this part is called principal part. So I'll just equal to 0 to infinity e n z minus z naught raised to n. So your all three types of singularity depends on this part only. So I'll just write it like this: b1 by expanding. So b1, it will be b1 upon z minus z naught plus b2 upon z minus z naught the whole square, and so on. And there will be somewhere bn upon z minus z naught raised to n, and so on. Okay, now three types of singularity are considered on the basis of this coefficient b1, b2, bn. So the first singularity, if the principal part principal, ये PAL वाला principal है, is the principal part of f at z naught contains at least one non-zero term, at least one non-zero term, but the number of such term, is finite. Then there exists a positive integer m, that is of course greater than 1, such that bm is non-zero, but after m, that is bm plus 1 and everywhere bm plus 2 and so on, anything, it will be 0. So bm is non-zero and everybody is 0. So your expansion would be something like this: f of z equal to summation n equal to 0 to infinity e n z minus z naught raised to n plus b1 upon z minus z naught plus b2 upon z minus z naught the whole square, and so on. It will end at bm upon z minus z naught raised to m, and after that everybody is 0 here, correct? Then this, in this case, the isolated singularity is called pole. So in this case, isolated singularity z naught is called pole of order m. It's called a pole of order m. Okay. If m equal to 1, then this is called simple pole. If m equal to 1, then this is called simple pole. Simple pole. Okay. So do you understand? In the power series expansion, if you are having a term bm such that bm is non-zero but everybody else is after that is 0, then we say that this is a pole of order m. Correct? Is that clear? So let me give some example. Suppose you are having this, say z square minus 2z plus 3 upon z minus 2. Okay, so what is the singularity here? What is singularity? Singularity means what? Where the function is not analytic. So at z equal to 2, the function is not analytic. But I can write this. So can I write the Taylor expansion of this? Yes. Look at this, z square minus 2z. Can I take z common? It will be z minus 2 plus 3 and divide by z minus 2. That is, this will be z plus 3 upon z minus 2. Still this is not in Taylor expansion form. Every one should be in terms of z minus 2, correct? But this guy is just z. So क्या करूँ मैं? Add 2 and subtract 2. So 2 plus z minus 2 plus 3 upon z minus 2. Do you see? Now this is in Taylor expansion in the form of z minus 2. So what will you say now? Does it has a pole? Does it has a pole? Yes. See, 3 upon z minus 2 is there. After that nobody is there of bm का एक भी term नहीं है. The principal part I am having only one term. So this has a simple pole. Simple pole. ये सिंगुलैरिटी को सिंपल पोल बोलते हैं at z not equal to 2. करेक्ट. एंड व्हाट इज रेसिड्यू? अगर बोला किसी ने रेसिड्यू निकालने को, तो रेसिड्यू विल बी कोएफिशिएंट ऑफ 1 upon z minus 2, that is 3. Is that clear? Correct. Let me give one more example. Suppose we are having this, say 1 upon z square into 1 plus z. Suppose this is a question. So what is singularity first? The first question would be, what are the singularities here? suppose if I am giving you a contour, say z equal to 0, what can you say? You are having two singularity, z equal to 0 and z equal to -1. So my question is, what can you say about this? Whether z equal to 0 is which type of singularity? So how will you do? You just have to write the Laurent expansion first. That is 1 upon, this is z square into 1 plus z. But you know how to write 1 plus z. This is 1 upon 1 plus z. Famous geometric progression, geometric series. That is 1 upon z square, put it outside. And here it will be what? 1 minus z square minus z. Sorry, it will be alternate plus minus. 1 minus plus minus and plus and so on, like this. So once you multiply z square to this, it will be what? 1 by z square minus 1 by z plus 1 minus z minus 1. Correct? Do you see this is in Taylor expansion now? This is in Taylor expansion form. You may write पहले ये लिख रहा तभी भी चलेगा, and then what is the pole here? So you'll see that this has pole at origin of order. What is order of this pole? Yes, what is order of this pole? Of course, this is 2, na? BM. So order is 2. So it is a pole of order 2. And what is residue? If somebody asks what is residue? Residue is coefficient of 1 by z. This is 1 by z. Residue is -1. Okay. Now let us go to the next part. This was the about first one. In the next one, suppose you are having all bn's are 0. Second case. उसको मैं first बोल देता हूँ. यहाँ पे. This is your first. Yeah. The case in which every coefficient in the principal part is 0. Correct? What do you mean by that? That means Bn is 0 for all n belongs to natural number. Then your function will be something of this form. F of z will be, it will have only analytic part. That is summation n equal to 0 to infinity en z minus z naught raised to n plus it is just 0. So you don't have to write. That's it. If you are having no terms of Bn, then this is called, then z naught is called, in this case z naught is called removable singularity. Singularity or singular point. Correct? So that is an easy case. See, अभी तक मैंने, I'm defining all the three cases by means of your Taylor expansion, by means of your Laurent expansion. If there exists some m such that Bm is 0 and Bm is non-zero and after that everybody is 0, then that m will be that z naught will be called as a pole of order m. This will be called as pole of order m. But if you are having all the bm's are zero, all the bn's are zero, then that case is called removable singularity. Okay, let us see some example. Okay, so suppose you are having this function 1 minus cos z upon z square. Can you write the expansion of this? How will you write? You know the expansion of cos z, correct? So let us put 1 upon z square outside. This will be 1 minus, what is expansion of cos z? Yes, what is the expansion of cos z? Do you see that z not z equal to 0 is a singular point for this? Z equal to 0 is isolated singular point. Now I want to know which type of isolated singular point is this. So I just have to find the Taylor Laurent expansion of this function. I know about cos z, that is 1 minus z square upon 2 factorial plus z raised to 4 upon 4 factorial. All even terms alternate plus minus. If you open bracket, you will see something. This 1 and 1 is gone, minus multiplied, so it will be 1 upon z square multiply with what? Z square by 2 factorial minus z raised to 4 by 4 factorial plus z raised to 6 by 6 factorial, and so on like this. If you multiply z square, it will be what? 1 by 2 factorial minus z square by 4 factorial plus z raised to 4 by 6 factorial, and so on. What do you see? Around, so z not equal to 0 is isolated singularity. And which type of singularity is this? Yes, which type of singularity is this? See, there is no term of 1 by z. There is no term of 1 by z, 1 by z square, nothing like that. Correct? That means all bn's are 0. So what will you say? Z equal to 0 is removable. Removable singularity, correct? And one more observation. What will be f of 0? What will be f of 0? If you put f of 0, look at this term. This everything will gone. I will be remaining with only first part. That is 1 upon 2 factorial. That is 1 upon 2. So that is a quick, nice thing to know. So why it is called removable? If you assign this f of 0 equal to 1 by 2, then this is your essential then this will be entire function when you assign this. So let me just write it. That's why it is called removable. That means if you assign the value of f of 0, it will be your analytic function. It will be there. Z not is not a problem for that. So you have to assign. So when the value f of 0 equal to 1 by 2 is assigned, f becomes entire. Entire function. Okay, is this clear? Yes. So this was second and third one. अभी क्या बचता है? Once you are done with bn, एक बार हम लोग ने फाइनाइट ले लिया, bn को all bn's को 0 ले लिया, तो what is remaining now? If an infinite number of coefficient Bn in the principal part are non-zero. That means Bn's are non-zero. Infinite Bn's, huh? Then Z0 is said to be essential singularity. Essential singular point. Yeah. So by means of your Lorentz series expansion, I defined three types of singularity. The first one was pole of order m. If you are having the Bm, at least one Bm which is non-zero, and others are zero after that, then that is called singularity. And if you are having infinite Bm's are not zero for infinite many people, then that is called essential singularity. So the example you can take, I'll write here only, e raised to 1 by z. What do you see? Do you see that z equal to 0 is a singular point? First of all, yes, z equal to 0 is a singular point, and you know how to expand this actually. This will be summation n equal to 0 to infinity 1 upon z raised to n into n upon n factorial. So it will be 1 upon n factorial into 1 upon z raised to n. If you expand it, so it will be 1 minus 1 plus 1 factorial into 1 upon z plus 1 upon 2 factorial into 1 upon z square, and so on. So there are infinite terms. It is not stopping somewhere, and all the terms of 1 by z are non-zero. Then this is called essential singularity. So you will see that z equal to 0 is essential singularity. What is residue? Residue is coefficient of 1 by z, that is 1. You see, and observe one thing, what is residue in this case? In the case of removable singularity, what is residue? Do you see there is no term of 1 by z, so residue is 0 here. And this is a famous thing, e raised to 1 by z, that is, it is a essential singularity. So and one more thing actually, yeah, so these are the three types of singularity which we wanted to know. Note one thing. Look at this function. Just now we saw about this function. This has removable singularity, correct? Let me show you this. Do you see this has removable singularity? And the question was, when we assign f of 0 equal